So we're back. I've summarized the results here. You have them already, but for me I had to erase them. So here I put my forces in black if they were in tension, in red if they were in compression, and this is where I'll list them now once we redo the whole thing for the virtual load, the virtual force. This virtual force is going to be one of the correct units in the correct direction. So we're looking for vertical. So I simply choose that I'm going to do a vertical down at the location of C. I could just as easily choose that I want to do vertical up, so that the force at C is going to look like this. That's perfectly fine. I guarantee you, perfectly fine. Because once you then put it all in the table, it all works out with the signs at the end. Okay? So your choice. You don't have to stress about, does that mean I do it up or down? As long as it's vertical, right? Because that's what we're being asked for, it's okay. Conversely, if you were looking for the horizontal deflection at C, then does it make sense that either you put a force this way or this way? Does that make sense? It doesn't matter what direction you put it in, because it then all works out in the table. Great. So now, I'm going to do this whole thing again, but for a force of 1 down. So I'm just going to sketch super quickly what this is going to look like. And I'm not going to be super precise about it because you already have it. So I have my AY, I have my BY, I have my AX, and I have my virtual force right here. I've chosen that it's going to be down like this. Okay? In the interest of being thorough, this is 3 meters. This is 4 meters. This is 4 meters. Like that. Okay? So we need to figure out what the reactions are going to be. Help me out. What is AX?
0.
It has to be. The only way to get equilibrium in this case is if AX is equal to 0. Agreed. Okay. Are we able to figure out what the value of AY and BY is? Sure. Yeah, absolutely. So we'll do a sum of the moments. Is it okay if we do it at A then? And we'll do, at your request, clockwise is positive is equal to 0. So sum of the moments with respect to A, we're going to get a clockwise moment of 1 times 4 meters, and a counterclockwise moment of By times 8 meters. That gives us that By is equal to?
0.5.
Lovely.
Kilonewton.
What are the units?
Kilonewton.
Okay. And
Positive.
because this is a positive number, it means it's in the same direction I guessed. Up. And now, even without having to go through the whole writing out of some of the forces in the y direction, how much is AY?
0.5.
It has to be, right? It has to be 0.5 because this is 0.5 going up. This is 1 going down. The only way you get equilibrium in the y direction is if this is 0.5, right? These two together have to balance out that. So I'll write it like this to recognize that you understand it. From some of the forces in the y direction, you get that AY equals the 0.5 up. So because I'm going to need this real estate, and I'll erase it in a moment, I'm going to transfer these values here. AY is 0.5 up. BY is 0.5 up. And AX is 0. Okay? That way I have them all in one saw. And I don't mind having to erase this whole thing. May I erase this whole thing? No? Awesome. Thank you. So now that we have the reactions, we're now going to go through the same process with the method of joints. Where do you want to start? A, B, or C? A? Okie dokie. So we have A, here's AC, here's AB. I'm looking for AC, I don't know what it is, so I'm going to guess tension. I'm looking for AB, I don't know what it is, I'm going to guess tension. AX, what is AX? AX is 0, awesome. AY is 0.5 up, like this. The only other thing we need is this angle right there. Okay. How much did we find that angle to be?
36.870.
And the other thing too that we found out was the cos of that angle was 4/5, and sine of that angle was 3/5. Correct? Okay, so whichever method works best for you works for everybody else. Okay, we're going to be clever about this. We're going to recognize that starting with forces in the y direction is the right one to do. Or the better one. How about that? The better one to do. Sum of the forces in the y direction equals to 0. We get 0.5 plus AC sine of the angle equals to 0. Which then becomes AC is equal to minus 0.5 over sine of the angle. What do you get for AC, please?
0.83333.
How much?
0.83333.
How much?
Negative 0.8.
Big difference, right? This is a check mark. Not this, right? Without that negative, in real life that's a 0. Right? Okay. Now that we have AC and we found out that it's negative, that tells us that it's in compression. Now let's do some of the forces in the x direction. In the x direction, we have AC times cos of the angle plus AB equals to 0. AC cos of the angle plus AB equals to 0. Solving, that's AB equals to this negative. I'm just going to put it explicitly. Like this. So what do you get for AB, please?
.67. Oh.
667.
Yeah, 667.
Like that?
Yeah.
But it would be
No.
0.666666666,
Not
right?
exactly. Okay.
To 3 decimal places it would come to be. So. Okay. Since this is positive, then that tells us this is in tension. Or you could just write it as 2/3. Okay. So now we have these two from doing A. Which one do you want to jump to, B or C? Which one do you want to do next? D? B. B. So B looks like this. So we have BC. We don't know what it is, so I'm going to guess tension. This is AB. We do know what AB is right here. So I'm just going to show it in tension like this. This is AB, and it's 0.667 in tension. And then I have a reaction of BY, which is 0.5. And lastly, I know that this here is the angle theta. Does that look okay for the free body diagram? Okay. What do you notice between B and A? They're a mirror image of each other, right? So are you expecting to get the same results?
Yep.
If done correctly, which we have, what we're going to get is we're going to get that the BC is equal to AC is equal to 833 in compression, 0.833 in compression. And then, if you were to do the sum of the forces in the x direction, you would then get that it's actually equal to 0. And then the last thing would be to do joint C to confirm that you do in fact get equilibrium. Okay? And in this case, because we've done things correctly, you should get that the x forces balance out to 0 and the y forces balance out to 0. Okay, this was okay? So now, the only other thing we have to do to really wrap this up is that final step. Set up the table and solve.